Hello, my name is Tom Elliott, and welcome to Tom's Aviation and Firearms videos. This will be a collection of videos dealing with both firearms, aviation, and machine shop. They can give you a prompt, they're not mounted straight. And the other thing is you can actually have machine error. And on this booklet, this is the owner's manual for the Newall DP1 1200. It talks in here about some of the different errors that you may get on this. And one of them, of course, is the DRO error. Mounting it, when you mount the sensor on there, it is supposed to be within 2/1000ths and about 3 inches or so the sensor length is on there, as far as both being straight this way and this way. So you have to indicate it. I think when I had on this one in one plane it was like 1/1000ths off and the other was like an inch and a half or 1.5 thousandths off. So they're fairly accurate, assuming they don't get bumped. The next thing that you have is the error on the DROs themselves, which are probably pretty close, but there could be an error. The other thing is machine error. And it talks about here on this machine error, different things as far as that you could have pitch axis, so it'd be changing the pitch, the roll axis, the yaw axis. So this thing could vary somewhat in the machine. Now obviously this is a fairly new machine, it's 17 years old, it has been used very lightly, and I have not put a lot of wear into this thing. It's just something to consider if you're buying a used machine. And there's also other errors in here they talk about on the stuff. Two types of errors as far as the machine goes. You have what they call linear type error. That means it moves off with a certain amount. You're going to move off that amount. So if I move 10 inches, 3/1000ths off or so is the error. That would be linear, or it'd be a linear area compensation. There's also segmented. This can also do that. So if I go at different points and measure how much error at each point, I can actually put that into the corrections into the DRO and it will take care of it. Assuming this is pretty much a fairly low used machine, any error that you probably see will probably be linear, and that's the way I'm going to compensate for it. Now, getting back to talking about this bar right here, this is a 10-inch standard. This 10-inch standard is measured from one end to the other. They use a laser to look at it, and there is a certification inspection came with this gauge block. It shows that I have a deviation of 32 millionths, so it's 32 millionths short or minus on this overall length of 10 inches. This is also measured at 68 degrees Fahrenheit, which is 20 degrees Celsius. They also give you a coefficient of thermal expansion on here if you want to figure how much it is for the variation of temperature. Temperature is probably right now in here is probably around 78 degrees, so we're about 10 degrees off. If it's based on that, it shows that we have a temperature, and we could go ahead and compute how much error there is. Now we're talking millionths of an inch, and this machine is not going to do that. Your cutters aren't going to do that. Probably you're someplace, if you do everything correctly, maybe 1/1000ths, maybe a little less. So you're looking at not really stacking of these errors, how you check this thing. So the bar is one way. Now I want to talk about how I'm going to measure that. I'll put this in this little vise here. I've actually taken a Brown and Sharp square, and before I tighten this up, I check to be sure that it is square here on the table. You do that so that you don't get the compensation error or the error twisting the block. So I'm going to put this in here and just lightly clamp this down so it doesn't move. And so I have the block in there solid. Now what I'm going to look at is how I'm going to measure from here to here. I have an indicator right here. This is by Heimer, I think it is. It is a made in Germany. It's a high quality one. This probe here is 100 thousandths. What happens is when I go across, this thing will move and it does 2 turns, 50 thousandths each, until you come to 0. That puts this dead in line with that edge. And then you do the same thing on the other side and figure out how much deviation you have on your movement of your axis. So I'm going to go ahead and put this into the mill. I'm going to be using my power drawbar. I have a 3/4 inch collet here. So I'm just going to lightly, and on the inside here there is a key that lines up with this. So you just place it in, be sure it's clear, no chips or anything, sort of wipe it out and feel it. And I've done this, collet's clean. Put this in, put it up, put this item in here, go to on. Usually twice does it on here. If you go more than that, what happens is this is a impact socket on here using on the drawbar. You can get this thing very tight in that taper. And if you do that, it takes quite a bit to loosen it. So it's usually 2 strokes like that. One to bring it up and one more just to do it. So 2 small taps. Now I'm going to go ahead and position this mill and I'm going to bring the quill down. I'm going to put this approximately in the center of this bar. Go to the far edge here. And the y-axis, I'm going to go ahead and 0 that. That way I have it on the same spot on the bar at each end. I'm going to lower this down. Lock the quill, 0 the knee, 0 the quill. Also going to turn around and now bring this up. As I touch this, it needs to go just a tad more down, center there, and 0 it again. So now I'm going to bring this up till I get second revolution and go to 0. Now, this gauge is marked in 1/2 thousandths or 5/10. There's some deviation, obviously, in any gauge like this or something that you have. It may be within 1/2 thousandths, maybe within 1/1000ths on their literature. So there is some stuff here we get into. So this is not setting the machine into millionths of an inch and doing this. We're looking at just trying to take the error out as much as possible and looking at probably around, if you really want tight tolerances, probably 1/1000th is going to be about your closest. If you need closer than that, you need to get into grinding and stuff like that. So we're going to do this. Now I'm going to go ahead and 0 the x-axis. Move this back out of the way. Take this up here. And then move this over to the other side. Go ahead and lower this back down to on the z-axis, z1 that is, and we'll go to 0 on that. Yeah, I've got it within a thousandths right now. And I'm going to now bring this up, same thing again, touch the indication, go 2 turns. And 0. Okay, if you look at this right now, this shows that we have 9980. So I'm going to go ahead and write that down. So in 10 inches for the x-axis, we have a reading of 9.9980. That shows that we are 20/10 off or 2 thousandths even in 10 inches. That is a pretty close looking at on this for error. Now I can compensate for that, and I will go into the DRO and do a compensation for that. Continuing our discussion on how to set up the DRO for the compensation of the error. We had the error was off 2 thousandths in a 10-inch span. Well, that works out to 2 tenths per inch, and if you convert that to microns, that works out to 200 microns or 200ths millionths of an inch. So what we're going to do in this is go ahead and set it up in here for compensation. So what I will do on that is I go into the menu, I go into setup, which is number 9, code is 1937, put that in. We're going to do axis 1, which is the x-axis, so I press that. We're going to go compensation, so that's number 7. I put that into the thing. We're going to do linear. I'm going to go ahead and put that in, which is number 2. And go ahead and go to setup. I'm going to go to program. And then I'm going to type in the amount. In this case, it happens to be 200 microns. Okay, it takes 200 more to get to my desired reading, so therefore it is plus 200. If it was over, then I would use a minus sign or minus 200. I could change the sign by pressing this right here. Once that's accepted into the system, I press enter, and then I exit the system. Now when I go back and check it, I want to ensure, starting again at the 0 point or whatever point, checking the gauge, and then going back over here to the full length. And doing this on this equipment, I have found that the error now shows exactly 10 inches, and it's 10.0000 or 10, measured in tenths of an inch. Now, that compensates for that. And next I'm going to set up, and I'm going to have a short break here, and I'm going to set up the y-axis and do that. Basically the y, the z axis will be done the same in the setup. I just move this around. In the z-axis, I can actually go in, touch off of like the table, put one of these gauge blocks or Joe blocks here. And I got a 4-inch one. You can put it, stack it up against here where it's flat, then read it again, moving the table to adjust, and do the same thing on the quill. And therefore I can get all the axes to come up with compensation on it, so they're all measuring accurately. Now, again, like I've talked about, do I need it that accurate for actually using the mill? Probably not. But it does give me an accuracy to set up the table. I know my DROs are correct. And again, if you're looking at 2 thousandths and 10 inches originally, that's pretty good. It means this thing is set up pretty close. But it just checks everything out, sets it to where it matches. If you use a dial indicator, as some people want to do to check this, you can do that, but there could be errors in the dial indicator, depending where you're at. Even this piece of equipment here, I think, is within 1/2 to 1/1000th is the accuracy level. Anytime you measure something, there's always going to be some type of tolerance on your equipment. I like to use these Johanneson blocks or gauge blocks because they are calibrated. I do look at them, and it's probably the best way you can do it. Anything electronically can change. I have had sensors in the lathe when I was working on it, didn't realize it's changed, kept having problems holding diameters using DROs, and what it was, one of the sensors went bad. It wasn't too bad, it was $400 and some to replace the sensor, just put it back on, things up and running. Now, different DROs that you can get for all this, there is much more inexpensive ones. This is really industrial grade type. Newall makes them for basically the professional industry and stuff. There's a lot of stuff out there that's very good. Probably not as rugged, but it works very good. So it depends if you're at a home shop, what your amount of money is, and what you get. I elected to do higher end industrial grade most of my stuff. I find it's just a more accurate way of doing it. Well, I say it's more accurate. It's more rugged. Is it the accuracy there? If you check it, it may be just as accurate. I will have a video talking about micrometers, measuring tools, and some of the things on that and what I use to check them. And we'll get to that in the future. Yes, I'd like to clarify a few things on this calibration. I refer to tenths a lot of times. In the machine shop trade, at least in the US, we refer to tenths as actually 1/10,000th of an inch. So it's really not a tenth of an inch. So when I say this is off 3/10, I mean 3/10 of 1,000th. It can be confusing for people that's just learning this or just getting into it. Or if you're from a foreign country and we refer to tenths, it's not tenths of an inch, it's 1/10,000th of an inch. It's just a shortcut that's used in the machine shop trade. It's been that way for a long time. Now what I also want to show you is a close-up of this setup. This is the setup of the x-axis. I got this Heimer gauge on here, and it shows right now at 0, and I have the DRO showing from one end to the other, actually 10 inches. This has been adjusted. And so this is for the x-axis or the horizontal on the table. You can see how I have the clamp on there. Now when I also set it up to be sure that it is correct, I actually use a square. And this square, I go ahead and square it up with the vise here. And so that I'm getting a good square indication off both ends. And this is not tipped anyway on the table. This is the best way to, to calibrate it. Again, like I've said before, you probably don't have to you're just verifying a lot of what this is. This is within millionths of an inch as far as the calibration. The table, the problem that you get into it, well, you can do that. These digits show 2/10,000ths of an inch. There is some variation of how accurate they are. And so it's probably not as precise as it shows because there is some standard some deviations in that. This is looking at the setup for doing the y-axis. I'm also using the 10-inch Joe block here, or gauge block. The term Joe block and where it's used, the original names of this was Johanneson block. There was a guy named Johanneson that he came up with these blocks for the automotive industry around 1900 or so for checking different things. And so his last name was Johanneson. And so a lot of times they refer to as Joe blocks. I think the official name to them is gauge blocks. So, but anyway, this is looking at it on your y-axis right here, and it has been corrected using the same thing. And but it gives you a look at the setup procedure, what I have on it. Again, I use the square to actually check this vise and be sure that it is actually square with the thing on it. So that you need to do. I think it's off right now just a tad, but that's basically the setup and using the square on the block. I will show you the vertical one here in just a moment. As you can see in this setup, this is the setup for the vertical mode. I use this both for the quill, which is Z1, and also for the knee, which is just Z. And what I do is I actually dial this indicator to 0, and this indicator not only doing X and Y, so you can go X in this direction or Y in this direction, it also has a vertical mode. And I zero it at right on, so you can see comes in at 100 thousandths, 50 thousandths, and then you zero it. Then I move it off to the side and do it off the table and measure the movement of both the quill and the Z-axis. I do them separately, and this is how I get the settings for this. This is based on a 4-inch Joe block, while the other I used a 10-inch Joe block. So then I go into the program on the DRO and calibrate it based on that. So this gives you a little bit of how I set this up. Again, I use the square to square that vise up with the table, and then I actually clamp the Joe block in here to the side vertically, and have a very good indication of what I'm at. So it gives you a picture of what I do with this. Yes, this is a series on machine shop. The first one was on the mill. I want to thank you for watching, and be sure to subscribe and hit the notification bell. Thank you.